great to be a part of this, and it's so exciting.
In the dark of night, the stars light up the sky. We see them flying free. That's just like you and me. Everyone is lonely sometimes, but I would walk 1,000 miles to see you rise. You are not alone, we're family. Hold me, let's escape all this reality. You are my symphony. By your side, we have unity. You are my energy, my guiding light. We are unity. We are unity. We are unity. Although the rain might pour, a thunder starts to roar. The lightning wakes the wave, but through it we are brave. Everyone is lonely sometimes, but I would walk 1,000 miles to see you rise. You are not alone, we are family. Hold me, let's escape all this reality. You are my symphony. By your side, we are unity. You are my energy, my guiding light. We are unity. We are unity. We are fireflies, a million little pieces, feeds the dying light and brings me back to life. In your eyes, I see something to believe in. Your hands are like a flame, your palms are sweet as pain. Let the darkness lead us into the light. Let our dreams get lost, feel the temperature rise, baby.
Struck DMP address takes a char.
We're not in love, we share no stories, just something in your eyes. Don't be afraid, the shadows know me. Let's leave the world behind.
Alright, char DMP address. U16 port. Did it just try to compile the object files? I hope not. That is bullshit. Ah, I know what's happened. No rule to make simply block device. We don't have that anymore. Ah, I've left it in the make. Easy mistake. That was that was yesterday's work, which I've ditched now. Okay, I made a mistake, guys. Oh, good. It's alright, we'll fix it. Okay, I figured out why there's a problem with this. It's pretty obvious, actually. We have to pad. God, this seems like such a hack, honestly, right? Anyway, which file is that in? Yeah, I won't be able to include that. Yeah, so if we pad that now, maybe now it'll work, right? Let's give it a go. Alright, that still didn't work. You know what? This is annoying now. 1 second. Let me just look at this a minute because I want to see how they do this. I can replicate them. So they have an RC address. What's that? It looks like there's a protocol you have to follow or they kick you off. So they have an SA family T. So it looks like we need this as a must, right? And then after that, yeah, that's completely accepted. So I'm guessing it's because we don't have a family why this is a problem, right? So we're going to change this now. And we're going to put that there. And then we're going to try this again. We still see a problem. Oh, fuck. I know why. Sorry, guys. I forgot to ensure the kernel was binded. let's remove that as well now. Starters, that's in the wrong place. We try that now, make that.
You may be gone, but you're still right here. And I can see you clear as daylight. I will spy you in a starless sky, see you clear as daylight. I will find you without satellites, see you clear as daylight. I will spy you in a starless sky, see you clear as daylight. I will find you without satellites, see you clear as daylight.
Alright. Why is this failing? I wonder. Hey, not bad, not bad. How are you? I've removed the the work I did last night. I got rid of because I've thought of a better way. So far, that way isn't working out so well because it looks like there's a few restrictions. So I'm trying to figure out how to make these custom sock addresses because it's not as simple as just creating a structure and passing a pointer. Apparently, I think it does some checks. Like, I think the family field here might be required or something. I'm not sure the reason, but I'm trying to figure it out. We'll see, we'll find out what it is. I'm looking into the Bluetooth module to see how they do it, and then we can borrow from theirs. And do we mem set it? Let me check. Yeah, we mem set that. That's fine. So you can see I got DMP address there rather than sock address in. So we will send that. You see in the kernel the Bluetooth structure for that represents the address. There's nothing special about it. You can see that. It just contains simple fields here. I'm doing great. Had a nice progress there. Really good. Really good. Glad to hear that. Yeah, I almost got hired today to do a job in Python. Python and C. I'm going to make a Python module basically. Well, yesterday's work we're now scraping away. We're not going to do it the same as yesterday anymore. Instead now what we're going to do is I'm going to put something new on. PC's really lagging out today. Can't even pause the video, right? Yeah, basically yesterday's work I created a device driver, character device I created in the driver to allow communication, so we can talk to the kernel module like a almost like a talk to the kernel module almost like a what's it called again? A file, almost like a file. But that was a really bad design choice, so I'm getting rid of that completely now, and instead we're going to rely on the address structure to decide what we should do. Basically, because it's decentralized protocol, you know, you need the ability to create new addresses. So what I'm going to do is, if you don't provide an address, it'll generate one for you. And that's the design I should have gone with, but I didn't. But I'm going to go with that design now. So there we go. Yeah, send me it on send it on here, because I keep getting bored of the tunes now because I'm listening to the same stuff all the time. So alright, let's look down here then. So I need to find out why this is being rejected in the kernel, because it isn't even getting to my module when I've tried to make my own address, right? Did I say my kernel? You know what I meant, my kernel module. So I know the SA family T isn't included here when I have to find a header that both user space and the kernel can use, otherwise I'm going to have to use definitions, which I'd rather avoid. You see, unknown type name. Let's just deal with that now, hold on. So actually, no, that won't work. That won't work. Will it? Yeah, that could work. That could work. Hold on. Hold on. Yeah, no, I'm not going to do that. I was going to just basically put my header underneath that one so that it resolves it, but it's a bad idea. That'll come back to me. Cool, let's listen to this. So it'll be an early night tonight, so I won't be able to work as late as I'd like to. I'll be finishing up at 11. Yeah, that compiles just fine, I think. Let's just compile the other thing now. Great, they both compile now, that's good. Okay, brilliant. We did it now. So that now works, which is great because now we can have our own custom addresses. Which I can't believe I didn't think of this before, right? Last stream I spent 2 hours overcomplicating something. But it really was as simple as creating my own structure and passing the pointer, I guess. So now we have DMP family. I'm going to change this from RC family to family. Hold on. Oh, to be honest, is there much point in even having that? The DMP address gives it away. Let's get rid of that. We don't need it. Let me just make sure that the kernel doesn't expect that to be set or something, right? Because it might cast it to its own internal mechanism, right? And then check if it's 0, you know. And then if we don't follow the same, if we're not binary compatible, then there's a problem. But I'm just making guesses now. Right, what's this? Sorry, hold on. Can you touch a bit while you're designing decentralized network kernel? What are the possible? Okay, yeah, sure. When I started DMP, originally it wasn't a kernel thing. It was a library. But then I thought to myself, I'm overcomplicating this on a high level because I was creating basically this system where you could store blocks of data around the world, decentralized. But I realized quickly that there needs to be something more simpler, something more fundamental, right? It makes more sense. And you build on top of it. Like the guys that made TCP, they didn't say let's make HTTP, did they? You know, you made TCP first and then it's building blocks. So I wanted to make the fundamentals. So I thought, okay, we'll make a bare bones protocol that just does what it says on the tin, very simple. Like TCP, for example, is quite simple, right? Let's say UDP. UDP is quite simple, right? It's a simple protocol, right? So the same applies here. DMP will be a simple protocol. I forgot the question. Hold on. What are some of the possibilities with it? Can you touch a bit on why you design? Yeah, so the possibilities are that you can send packets. You can send packets to people that have guaranteed delivery, and when I mean that, I don't mean in the same sense as TCP. What I mean is if they're offline, they can still get the packet. It can be queued in the network, and when they're back online, the packet can be sent to them, which is an interesting feature that I haven't implemented. I might implement it, I might not, we'll see. The second reason is that your DMP doesn't work with IP addresses. You don't send to IP addresses. You send to IDs like this. You send to IDs like this thing here, right? That's 33 bytes. Oh, that's fine. You send to IDs like this, right? And what happens is it gets sent to the network through IPv4, and then it gets bounced around till it reaches its destination. The people using the protocols have no idea about how the IP addresses involved. They don't talk with IP addresses at all. It's completely abstracted out to them. But that also means it can follow you. So if you go to the coffee shop, your DMP address stays the same. That's not the case when it comes to IP addresses. Not only that, you can have an infinite amount of DMP addresses where you can only have one IP address per network, right? So if you know, you can have 1,000 DMP addresses for one computer to represent different programs or whatnot. So yeah, there's a lot of possibilities with it. Basically, you can build decentralized applications with it, but it's the bare bones by design though, right? Alright, cool. Alright, let's go back to this now. So we no longer need that. Let's see if this thing still works. Basically, someone can send a packet to your DMP address, and you can be anywhere in the world and receive it. The internet doesn't work like that with IP addresses, because my IP address is like your telephone number, landline number. I mean, it's like your landline number, right? It's stuck in your address. It doesn't follow you, but DMP does. Think of something like decentralized mail, for example. Imagine having an email address that had no central point. You know, with DMP you could make things like that. You know, stuff like that. Obviously you couldn't send to other email addresses because they use different protocol, right? But if they all used the DMP version, yes. Alright, let's listen to some rap or something. Star Wars rap, or why not? Could work. Funny. I haven't really read anything about it. I don't even know if someone's done something like this or not. I know you got Bitcoin, it's not the same thing. Because mine's kind of like a fundamental protocol, like UDP, for example. I haven't... Send me that paper if you know where it is. I'm interested to read that. Alright, cool. Let's carry on with this.
Pajamas, celebrity, so you don't want no drama. I'm a rebel, see, we shoot slugs like Jabba, and if you talk back, you go back to the Jawas. Programming way wrong, obtain a new brain mod. You won't survive around, yo, you need an escape pod. You're not... Okay,
there we are, that's good. Oh, bugger, sorry guys. One sec. Yeah, no, that's completely fine. That's because I should have done a full rebuild there, because I changed headers, right? That's why it says there's an error here. So we'll do a full rebuild here. Oh really? I mean, you know, it's gonna head this way, right? And I'm not saying everybody's gonna use my protocol, but something similar and probably better will be made soon enough. And then when that happens, it's gonna change things. Imagine turning on your social network and you're not actually connecting to your social network. You're connecting to everybody else who sends your profile to you. You know, that's what I think the future is going to look like. And it's better that way. No centralized point means governments will struggle to take things down, bring power back to the people, really.
hold it down. All right, to my right, Darth Hater. To my left, Princess Slayer. DJ, spin it, let's go.
Alright, we need to find out why this is happening, because this shouldn't be happening now. 36 was provided to us, we're expecting 34.
This win is something you could never do. They're wanting episode 7 of Phantom Menace Part 2. I'll stick your charred face between a rock and a hard place. The only thing that you could ever win is a pod race. And as a matter of fact, Dad, I know that you can't spit, cause every time that you be breathing, you be sounding like you're sick. I don't hate him, but I hate him cause we know.
You know when you can't think of a song to put on? That's the state I'm in. Alright, let's look at bind then. If length does not equal the size of the structured DNP address, then we have a problem. Right, I know what I've done wrong now. I haven't rebuilt the user side. That must be it, right? Jesus Christ, I haven't rebuilt it. Let's try that now. Try that now. Yes, it works fine. There's me rebuilding the whole kernel module. Unbelievable. Right, can't think of what to put on. I want a song on, but I don't know what to put on at all. Let's try a bit of Linkin Park rap or something, I don't know. I listen to piano. Yeah, trance is amazing. I love that genre, but for some reason I'm not feeling it today. I don't know why. Maybe because I've listened to the same songs a bit much. Numenko is a classic. Alright, cool. Right. Let's carry on with this.
I think this is the loudest you've been all night. Thank you guys very much.
I think they could get louder. I think they could get loud.
A little louder?
I think they could get loud.
Can you guys get a little louder?
See what I'm saying?
Alrighty, that's good, guys. Works fine. Alright, now this is where the magic's gonna happen now, right? What I'm gonna do, I'll listen to that as soon as this song finishes. What I'm gonna do now, I'm going to oh God, I keep losing my train of thought. I'm going to now try and set the address back in user space, which is gonna be really interesting. Because if they don't provide one, I want to create one and set it. But I don't know if I can. I might be protected, memory protected, so I could crash something doing this. Let's try it. Mine or yours? Is it my PC or yours? Because I might be streaming at too high a bit rate. If that's the case, I'll reduce it. Alright, watch this now, right? This is going to be really interesting. We are going to try to set the address to 0. If we can. If I can. It's going to be quite interesting, actually. So I'm just going to do 3 zeros for now, and if just to see if this works, right? And if this works, I'm going to be very happy because it means that I can transfer this data back. If it doesn't work, then we'll try and find a way, or find the correct way to do this. Oh, really? Okay. Tell you what I'm gonna do then. I will. I'll pause this video and see if it helps. I think I'm downloading too much. Tell me in like 2 minutes if it's still bad. How bad is it? Is it unbearable, or can you still see what's going on?
Yes. Yes. You ready? Let's go. Yeah.
All right, let's try this.
They wanna know what we're all about. It's like this, y'all. This is 10% luck, 20% skill, 15% concentrated power of will, 5% pleasure, 50% pain, 100% reason to remember.
So what do we do now then, guys? As soon as we bind, we are going to output. We're going to output. I'm going to crash the program doing this, by the way, because there's no terminator. But never mind. I'm going to output the address. I'm going to output the address by here. And if we see 3 zeros at the start, then this was successful and I can continue with this plan. We don't. Which means the kernel probably copies it. They probably copy it, which is an issue for us, right? I'm going to put your song on the other. I know now to reduce the bit rate next stream. So what we're going to do then, we are going to try and figure out why this didn't transfer back. I really don't know why. I think the kernel might be copying it and giving us a copy, in which case we're basically screwed. We're going to struggle to get that right, really. Unless... not really my type of music. Well, unless there's something we can do, right? I can have it so you pass in a pointer instead. And then we read from user space, and then that should allow us to set it, right? Let's give that a go. I've never tried this, so I don't know if it's going to work or not. First, I'm going to just double check that this is a kernel problem. You see, because we copy 000 to the address, so we should be seeing something a little nicer coming out there, but that means they've copied it. The fact we don't see the changes on the other end means that they've probably copied the structure before giving it to us here. The kernel's probably copied it, I mean. Yeah, we still don't see it, guys. So I'm going to make that assumption now. What we're going to do instead, we're going to pass in a pointer instead, and we're going to access it from kernel space. I'm not sure if that's good practice. I don't know enough about this. but we'll do it anyway.
When the waves come crashing down and you feel you're
So how does this look then? Well, let me show you.
gonna be there to pull you out.
This becomes a chart pointer.
Times there'll be pain. Whatever obstacles we face, we can do it all.
And there we go. That's how it looks.
You're the oxygen I need to survive.
And we should be able to access it from kernel space, I think.
You'll be there by my side. Now I'm begging you, please don't take this lifeline from me. When it's the only
Only issue is we now have to actually free the memories, so it's a bit of a pain, but yeah, I want to try and keep this as tidy as I can, so I'm going to probably change the design a little bit as I go along, right? So we're going to go hello world. No, we're not. We're going to pass in this full thing here. There we go. So we're going to pass that in. In this case, we don't have to free it, right? Because we know the ID. But in a case where we didn't know the ID, we'd have to do that. If we allocated it in not a compile time, we'd need to free it, right?
So I will be there by your side.
Unless they used a local buffer or something, right? Anyway, never mind. I'm coming off topic here. Right. Let's now call our little set function. See what happens.
And if you stray too far from shore, and you're lost without a cause.
So now we just do this instead, right? Address, rather than getting the ampersand, we do this, copy the user. Seems like it could work. Let's give that a go.
When I'm running out of air, you'll be there.
Ah, wait. I just did something really stupid. We can't change that. That's global memory, right? That's like we shouldn't be doing that. That'll probably crash actually. Pretty sure. I don't know anymore. Alright, give me 1 sec, Let me just test something, because I can't actually remember now. I'm being stupid. I'm wondering if there's some memory protection set up there to stop us overriding that. Yes, there is. That was what I thought, right? That's no worries. What we're going to do instead then is we're going to allocate by here the address. DMP ID size. There you go, perfect. And now we pass the address of that. And there we go, now we're safe to do it.
We were living a lie and looking away, floating inside some
1 sec.
ourselves and losing control.
There you go.
We were so far gone, but then underneath
Alright, let's compile the module.
it all, there's something beautiful like a fallen star. You show me not to let it go. All over again, time after time. I never believed it could be mine. A flash in the dark when nothing was right. When I'm with you, I feel alive. I
And now ready? Look at that. That worked, guys. 000FFFFF. We did it. Brilliant. And you might notice we segfaulted down here according to the kernel log. We segfaulted because I don't have an old terminator, so I knew that was going to happen, right? Don't want to segfault anymore? Fine. Wait a sec. We're just going to pass in a... we're just going to take away one of the F's here. And now if we compile that... See, we're in kernel land, so we can basically do what we want. You know what I mean? That's why I knew I could write that user space address. It works. Well, with great power is great responsibility though, right? I've actually broken a computer or two doing this kernel stuff. There you go, no more segfault, cool. So, now are you on a VM? I can't go on a VM. Even you know the performance problems, right? This PC is like 6-7 years old now. I can't actually cope with the, I can't cope, it just can't cope with it. If I stream and then go on VM same time, nothing's gonna happen. Now what I could do maybe is I could strip down, I could get a really bare bones Linux kernel with very simple operating system from like 10 years ago, 15 years ago, whatever, I don't know, how long ago? I don't know, you know what I mean? And then maybe the PC could emulate that a little better. But I'm not going to do that just yet. Plus, then I gotta get this kernel version compatible with that. You know what I mean? Anyway, this is good, right? Look what's happened here now. So, you do put in a little bit more work, but that's because bind for some reason copies it, which is really annoying. I assume they do it because so you don't have to use special routines to access the memory. Because if we look at copy from user, copy to user. You can see it checks if you have, I don't know, what is that, access, maybe it checks you have access to that memory region, maybe like checks that there's a page for it that you can access, maybe, and then get fs, I don't remember what that does. Current thread info address. See, I used to think that meant get file system. I'm an idiot. Alright, let's get back to it. I'm coming off track. We know it works. That's all that matters right now. So what we're gonna do then? Well, what I'm gonna do right now is I'm going to copy from user. That's the first thing I'm gonna do. And then we're going to check if the address is null. You know what, we can do that here actually, yeah. If the address is null, no, we can't do that for there. Alright, if the address is null, there's a problem. Right, that's the first thing I need to do, because we need to make sure that never happens. Kernel error, and then you have a problem. Alright, so kernel error, what will happen is we go kernel error, and then, one sec. So we go kernel error, and then we're gonna say you must provide an address. Nice, simple, and then we return invalid argument there. Nice. So how do we represent when there is... Alright. How do we represent when we need to create this for them then? Firstly, the reason they have to pass us an address is because we're in C right now. You know, right? I can't just create memory for them because then I'll be responsible to delete it later on. So we can't do that. Okay, I guess if they provide us an address with all zeros, then we generate them one. I think that's fair, right? I think so. Alright, let's take a look at that. To, from, long. That's fine. And I am going to test some stuff as well, guys. Try and make really stupid things happen to try and break the kernel, right? Because it's important to test these things. Ah, shit. Do you know, I just thought of a vulnerability, actually. We have one problem with this design, and that is somebody that wants to steal data that isn't theirs could pass the address. No, don't worry. Don't worry. I think I'm okay, actually, because these are virtual addresses, right? I will need to make sure, because I'm wondering if it's possible someone could hijack data from someone else's process, and that is obviously cannot happen, right? So we'll test for that anyway. That's no worries. Yeah, I think it's okay because it looks like it gets the current thread. You see what I mean? So I think it'll always resolve to that user program. I think we're okay, but I do need to research about that just to make sure. I'll do that in my spare time. Alright, what next then? Well, let's put that there for starters. Next, what we need to do is we need to actually compare that now, and if it's 0, then we'll generate them an address, right? Did I really forget the actual syntax for string position? One sec, guys. Ah, no, that's not what we want. I'm getting so confused. Hold on. So that relies on null terminator. We're not using that. One second. I can't believe I forgot how to do this. Mem compare. That was it. What's wrong with my memory today? Honestly, right? Okay, so what do we do now then, you ask? Well, we're going to make a definition for this, but it'll be like this, right? 1, 2, 3, 4, 5, 6, 7, 8. 32 of those. Alright, 32 of those done. So if they provide to us this, then what we do is we generate them a new DMP ID. I may change the syntax before release. Ideally, I'd love to rely on null terminators. But unfortunately, if I did that, I would be responsible for the memory. I can't allow that. Yeah, that's correct syntax. Alright, cool. This should be changed to a definition, mind you. Do you know what? Actually, I'm being an idiot here, aren't I? I realize that now, yeah. Why don't we have a flags? That makes much more sense. You know, this is the problem when you work this late at night, right? It's 11. I'm going over schedule, but it's fine. It's the problem when you work late at night is you don't think as quickly on your feet, right? So yeah, we're gonna have a flag then. That works. There we go. Now this is more interesting, right? Because now we have flags. So what we can now do is we can do crazy stuff like this. We can go DMP flag. No, DMP address flag. Spawn address. I don't know if spawn's the right word. Generate address. There we go, cool, looks better, right? So now if that flag is present, then oh yeah, one other thing, right? This is bit masked, so it needs to be needs to be like this. I always do my bit maths in binary. They're easier to follow in my opinion. Because it's literally like switch on, switch off, right? So it's either 1 or 0. It's easier to follow, in my opinion. What's this? Sorry to leave you hanging. Need to take off. Wait, want to do a bit? Yeah, sure, enjoy. Yeah, you know, I'm gonna follow you actually. I'll check out your video tomorrow. I can't actually find your channel right now. I'll just add you as a friend. I'll follow you later. Okay, so what do we do now then? Well, now I need to actually set that flag here on user land, but we're in kernel land right now. So the first thing we do is this. So if they pass the generate address flag, then we now know we are responsible for generating a new address for them. So just in this example, all I'm going to do is just actually all I'm going to do is just change their address just for now, right? Manually, but tomorrow I'll actually elaborate on this and it'll actually generate a real DMP address for them. But it's all slow progress, this is, because it's just, you can't rush these things. It takes time. Alright, so we're going to copy that to the user then. Brilliant, if they pass that flag. Alright, let's test that and then I'm going to call it a night myself. That works, brilliant. However, it sets the 3 zeros even though we haven't passed that flag, which is not very good, right? I think I forgot to remove the mod, did I? Yeah, I forgot to reinsert the mod, guys. I'm an idiot. There we go, that's good. Alright, so now watch what happens next. What we're going to do, we're going to go into here. And we are going to actually change we're going to set that port. And we're going to try that. And then there it works. Brilliant. That's really good, guys. Really, really good. Okay, now let's pass in a fake address. And this will be our final test, right? Okay, good. So the kernel caught that. Let's put in a different fake address. Alright, that was a little worrying. Because it actually passed. A little worried about that. I'm not actually overriding real memory right now, am I? Ah, okay, I know what I've been doing now, why we didn't notice those things. I'm going to quickly do that, and then I'm going to come off here. There we are, that's what I wanted to see. Okay, cool. Stream next time.